All right, good evening, everyone.
Good evening.
And today we are going to start with our questions from Leetcode, right? So it is going to be very interesting, of course, right? All right, good evening, everyone. And voice testing is also done. So now we can start with it. So the first thing I'm going to do here is I'm going to share my screen first of all. So let's share the screen. All right. So these were the questions that we were trying to do yesterday, but because of the time limit, we stopped at I think two, three questions, right? So today, first thing that we have to do today is that we have to basically see through all of these questions, right? And maybe by tomorrow we'll start with dynamic sliding window concepts as well, right? So this is clear to us, right? That what we are trying to achieve here and what we are trying to do here, right? So we are going to start with some lead code questions, right? So are we good to start here? Can we start the session now?
Yes, ma'am.
Yes,
Ma'am.
or
Yes, ma'am.
Yes, ma'am.
okay. So let's start with this. So the first thing here is that we have discussed 2090 questions, and have you people solved it as well? The 643 and 2090. Have you people tried these questions?
Yes, Yes, ma'am. Ma'am.
Yes, ma'am.
Yes, all right. So let's just start with the next question, right? Which is 1100, which is find k-length substrings with no repeated characters. So let's start with this particular question. We'll try to see that what they're trying to ask us in this question. So let's read the question first of all. All right. So we're going to see this question from Algo Monster. So first of all, let's read the problem description at what they're trying to ask here. All right. So they're saying that you are given a string s and an integer k. So you are given with two inputs, right? The first one is one string s is there and an integer k is there. Acha, by the way, all the problems that are not available on Leetcode, and if you want to see, like, you have to go for subscription, and but still you want to see those questions. So Monster like provides you with all the question statements, so you can come here and watch these questions here, right? So you're given a string s and an integer k. So two input values are given to you. Your task is to find how many substrings of length k exists, right? In the string s, where all characters in the substring are unique. So, for example, suppose they're saying that, for instance, if let's take one example, if s is equals to have fun on Leetcode and k is equals to 5. So you have to check all consecutive 5 character windows in the string, right? So the first task is that you have to go through all the windows of length 5 in have fun on Leetcode, right? And what is the condition that you have to check for? So the condition is that all unique characters should be there in that substring, right? So if we will consider, suppose this particular string, which is have fun with Leetcode, and we'll paste it over here, we'll change the color to white as well. So it is asking us that if suppose the size of window, which is the value of k is 5, then how many such substring can you form? So the value of k is equals to 5, right? So now they're asking that if suppose the size of your window is 5, so how many such substrings can you form in which all the characters are going to be unique? So you'll say that the first window itself is containing all unique characters. So H, A, V, E, F, all are unique, right? So this is first window. Then you will move this window by 1 unit, that is, you'll slide it through, and then again you'll see that this particular window is also containing all unique characters. So now the count of unique character substring would be 2, right? So you just have to update the value of this count. Now, if you'll move it even further, then again, V, E, F, U, N, again, all the characters are unique. So number of unique character strings would be 3. Then again, you're going to move this window, and this time also all the characters are unique. So the count will become 4. Then this time the count will still be 4 because now N is repeating itself. So still the count is 4. Then again, you'll go further, again, 2 N are repeating themselves. Then here also 2 N's are there, then 2 E's are there. So this is how you have to basically slide the window throughout your string, and you have to find out that how many such substring exist in which all the characters are basically unique, right? So this is your problem number. Which problem is there? This is your problem number 1100, right? So this is the complete problem description. That is, you have to slide your window and you have to find out, slide the window and find out all the unique characters substring, right? Unique characters substrings you have to find out. So again, a very simple question, right? Again, a very simple question. So you just have to slide the window. You have to find out that what all substrings are there. So now the point is that how do we find out that in a particular substring, all the characters are unique? So now we understood the problem description, but now we have a smaller problem that is inside it, which is that how do we get to know that all the characters that are inside this particular window are unique, right? So this is our question right now. So what can we like use here? What approach can we use here to find out that all the characters here are unique?
Ma'am, we can use hashing along with this and keep a record if the number doesn't exceed 1. If it exceeds, ma'am, we will move the left pointer towards right.
Absolutely. So we are going to do something of this sort only. So our approach is that suppose if our string is something like this, right? S is equal to, this is our string, and let us suppose that there are these characters inside this, right? So, so something like this, right? And now let's assume that the value of k is equals to 3, and we have to find out then in each of the in each of the sliding window or in each of the window, are all of these characters unique or not? So we are starting with the very first window. So this is our first window, and we are going to make a hash table or hash map. We're going to use a hash table or hash map to solve this problem. So we're starting with a hash table, right? So this is our hash table, and this hash table is basically an array of length 26, and length 26 because we know that there are going to be only 26 characters, right? Because in the problem statement this constant is given that you'll be given only the lowercase characters. So we know already that there are going to be only 26 characters that we have to take care of. So that's why this array is having a size 26. Right now here 0 represents a, right? You people know this, that how to map characters with the array, or how to make a hash table out of this array. So you have to map your 0 to A. So basically here 0 is representing A, then 1 will be representing B, and so on, so on. This is suppose C, so 2 is C. Then somewhere here E will fall, right? So at some index, so at index number 4, A, B, C, D, E, index number 4, you will have your E, and after some index, at particular some index, you'll have your h. Somewhere around here you'll also have some h, right? And in between there are other characters as well. So this is how we have developed our hash table, which is of size 26, and it is a simple integer array. Right now what we are saying is that let's just start with the first window. So in the first window we have got our first character as t, so we're going to mark here as mark this place as 1. 1 simply means that in this particular window, we have got this t for one time. Then we are moving ahead, and this time r is here. So R, S, T. So somewhere here R will also be there, right? So suppose this is R. So we have to increment the count of R as well to 1. And then E is coming here. So E is also marked as 1. Right. So now we have mentioned here that these three letters are there and we have marked them as one. Now in the checking part, that is once you have completed your or filled your hash table, now you can check all of these characters that how many count have occurred for each of them, right? Or otherwise you can use one more technique, which is that you can keep a counter over here, right? And this counter, what it is doing is that if any of the repeating character is coming, then the counter will not increment. But if you're marking this count to a character which is not having any value before, that is, which is marked with some zero value, then it is going to increment the counter. So now at the very beginning, when you were incrementing the count for t, counter will be incremented to 1 because this is the counter for all the unique characters only, right? So counter is incremented to 1. When you are inserting the value to R, then the counter will be incremented to 2. When you are inserting the value at this E position, then this counter will be incremented to 3. And if the size of window and number of unique characters, if they're equal in size, it means that you have found your first unique character substring, right? So you can basically say that we have find one of the substrings. So we are going to increment the count of substring by 1. Then we'll further, we'll further go and we'll basically check our next window. And inside the next window, what you have to do is you have to simply remove this one count from t. So you're going to do a minus minus, and that's why this t will become 0. And because this new e is coming, right, and because this has become 0, so you have to decrement the count of unique characters as well. And then this next character is coming, which is e. So at this position, you're going to go to this E and you have to mark here +1, which is making it to be 2. But now, as you're not incrementing the count from 0. That's why you're not going to increase this counter count as well. So you need uh, values counter is going to be 2 only in this particular case. And as after like traversing through this window, as we have understood that there are only 2 unique characters which are not mapping or matching to the value of k, that's why we'll not increment the count of substrings as well. So this is a repeating case, that's why we are not incrementing the count of substring. Now we will further go ahead and we'll check that what is the next case. So here R is going out. So whenever a character goes out and it becomes 0, at that moment you have to decrement the count of this counter. So 2 minus 1 will be equals to 1, right? But there is a new character coming inside as well, which is C, right? So C is also incrementing its count from 0. So definitely you're going to increase the counter value to 2. So now again, after traversing this window, after checking this window, again we are getting the count as 2. But we want it to be equal to k, which is not happening in this case as well. So that's why we are not going to increase the count of your substring, number of substrings as well. Right, then again we are going up in the right hand side, and this time you are basically removing this e from here, right? So e has to be removed, and when you remove this e, the value of e will become 1, right? So it means that unique character count cannot be decremented, because it can be decremented only if your value of e is becoming 0. Right, then the new character that is coming inside is h, and because h is, we are adding up a value to 0 because it is becoming 1, so that's why you are going to increment the counter value as well. So this time the value of counter and k is equal. That's why we'll say that now we have got one more substring which is having all the unique character. And in the similar way, again, the last case will also be followed up here, in which E is decrementing its value to 0. And whenever a value becomes 0, we decrement the count of your unique numbers as well, unique characters as well. So it has become 2. And a new character A is coming inside. So we are going to put this we're going to do a plus plus, which will make it plus one. And you people know that whenever it becomes plus one, so unique character count will also increment and it will become three, which is equals to k. And that's how number of substrings that are unique in nature of size three are three. And that is our final answer. This needs to be printed. Simple. So this is how we have to implement this particular algorithm. Do you guys understand this?
Yes, ma'am.
Right? It was simple, right?
Yeah.
Yeah, so I want you people to try it for like 2, 3 minutes, and then I'm going to implement this as well. But first of all, you people try, right, because it is quite simple. Use this technique of hash table. If you don't want to use it, you can also use hash map or something, right? But start implementing this one, and then we'll move to the next question if there will be some sort of problem here, right? So this is basically your question number. Which question is this? It is question number
Lead.
1100. So you can try this one, 1100. You can try it on your normal code editor because you'll not have this one open on Leetcode, right? Yes, it is 1100. So you people can try it on your normal code editor, right?
मैम
Try this one.
एल्गो
Huh?
एल्गो मॉन्स्टर जो आपने वेबसाइट खोली है वहां पे नहीं कर सकते?
On Algo Monster, I think they provide you the solution. So you don't have to look for the solution.
Okay.
You people have to try yourself. I don't think that they provide practicing option as well. They're providing the lead code link. Otherwise, they give you intuition solution. We don't want that, right?
No.
You can try it on Neat Code as well. Ashutosh has provided the link. Is it done, guys?
Yes, ma'am.
All right, let us see this particular question, that how to solve it. Should I wait for some time or can we continue?
I'm wait for like 2 minutes maybe.
All right, all right. I'm waiting for 2 minutes. Guys, try. If you will regularly do this now, you can easily target any of the company. We just have to be consistent. That's it. And that's why we are starting very simply so that we can make, like, we can grow our pace, subtly. So that's why we are trying to do the simpler problem first, and we are taking a lot of time also in it, but that is completely fine. Once we'll achieve that kind of what we see, what we say, once we will be like kind of comfortable, then we can go like to any other level, right? And we know that we can go to any of the level, right? So we just have to be consistent throughout. That's it. Shall we try this particular question now?
You can
Or
continue, ma'am. Uh, I'll try on my own.
okay. So I'm going to help you out, guys, in this particular question, right? If you feel that this was okay, this was simple, then you can try it afterwards as well. So few of the questions I'll try it over here as well. So this is our question, lead code question 1100 dot java, and then inside this question we are having our, so first of all, this is our main function, right? And inside the main function we are going to have this string s is equals to, so whatever this string was there, we'll take the same one so that we can get the final outcome as 3. So it is 3 and then CHA. So let's put it over here, right? So this is our string that is given to us. And then there was one more input that was to be given, which was K, right? So K value we have taken as 3. So we're going to start the question from these two parameters, right? And then we are calling this function. So suppose the name of this function is get unique strings, right? Substrings or strings. So this is our function which is being passed with these two values, s and then this k. And what is it going to return? So it is going to return us the number of unique substrings that are there, right? So some unique number will come to us, and that we are going to print here. So we are saying that please print the value of this unique count. And then let us now make this function as well, which is static, and it is returning some integer value. So static int, and then get unique strings, right? And inside this we have passed two values. So first one is this string s, and then the second one is this int k. So these two values we have passed over here. Now, you people know that we basically, when we were discussing about this approach, then we used two values as well. One was the counter, which was basically storing that how many unique elements are there, and the other one was the count of substring. So these two extra characters, these two extra variables also we want, right? So int, this is substring count, and it is initiated with 0, and then this int unique counter, right? So it basically contain that how many unique characters are there, right? So we can name it as unique characters as well, right? And whenever the value will match with k, that is unique character value will become equals to k, then we'll say that yes, this is basically a unique substring. So we'll increment the count of our sub count. Now what happens is that we'll start with our first window, right? So this is our first window. Inside the first window, we say that let's start our loop starting from 0 and going up to k minus 1, and then I plus plus. So this is our first window. And inside the first window, what we're doing is that we are trying to, first of all, build our hash map. So, or hash table. So we are going to take a hash table over here, right? And the size of this hash table is going to be 26. So new int 26, right? Because here each of the single hash table variable is going to represent a single character, right? So 0 represent A, then 1 represents B, and so on. So that's why this hash table is there. And afterwards, this for loop, what it is doing is that it is going to fill up these places in the hash table. So hash table, at which particular index do we have to fill? So we are saying that first of all, extract this character. So char ch is equals to s dot char at, and this particular index, whatever character is there at this ith index that we want to extract. And afterwards, we want to basically subtract this character from A to get the index, right? Because if suppose the CH value is, let's say it is C, right? And it will subtract C minus A. So we are going to get some numeric value. So the value of C is basically when you will subtract C from A, the value that you're going to get here is equals to 2. And how is it happening? Because the value of A is 97, right? The ASCII code is 97, and the value of C is 99. So when you subtract 99 from 97, you're going to get 2 as the answer. So that is how we are reaching the exact index in the hash table. And then we are saying that at this particular hash table index, you have to increment the count by 1. So plus plus. So this is what we're doing, right? And while doing this, or otherwise we can do one more thing, that whatever this hash table value is there, if this hash table value is equals to 0, at this particular moment, we want to increment the unique char count as well, and we want to increment the hash table count as well at this particular place. Right, so this is a simple thing that we're doing. But if the case is other way around, that is, if the current number at this hash table index is not equals to 0, then we just want to increment the count of this hash table, but not of the unique character. So this is the thing that we need to apply over here. So we'll simply put it after this, because this is going to be done in both of the cases, but the unique character plus plus has to be done only if we are incrementing the count from 0. So this is the computation that we need to do for the first window. This is done. Now we have to go for the other part of this particular code, right? That is what will happen when we will slide through the window, right? But before that, one more condition will come, that is if the unique character count is equals to the value of k. If so is the case, then you have to increment the sub string counter as well, because you have got your first is- first substring which is having all the unique characters. Right now we can proceed further for the next character. So now we are going to start the value of I from k, and then I should be less than s dot length, and then I plus plus. So now we are going forward, and now we are saying that you have to basically remove one of the element from the hash table which you're leaving behind, which is the character present at I minus k position. So we are saying that first thing that needs to be done here is hash table at this position is needs to be checked, that is I minus k, right? Not I minus k. We have to first of all extract the character. So character that needs to be removed is equals to s dot char at I minus k, right? So this is the character that we have to remove from the hash table. And then there is one more character that we have to insert, right? So this is our new character, and the new character is present at caret index I, right? And now we're saying that in the hash table, you have to check that this removed character, if this hash table at this particular index, which is removed minus A, if it is equals to 1, right? And because this character needs to be removed, and right now if the unique index is equals to 1, then you have to decrement the value of unique character also, because now this unique character is going away from the window, right? And you also have to make the value of your hash table at this particular index to be 0. So removed minus A is equals to 0. If you'll do minus minus, then also the same thing will happen. Otherwise, if this is not the case, then you have to go for only this decrementation. So you have to decrement the value, that's it, right? You don't have to, sorry, this is what you need to do, right? And the second case is, what is this new character that is coming? So the same case will follow over here as well. And if this new character that you're including is equals to 0, then you have to do this unique character plus plus and hash table plus plus. Otherwise, you have to just increment the value inside the hash table. So instead of ch, this time we are going to say that we are talking about this new character. Right? The same thing is happening in both of the cases. And here also you can write this particular line once, right? If you want something of this sort, then you can do this as well. Right, so this is going to work in the same way. And after the complete processing of a single window, then again you're going to check for this particular condition, that is, if the value of unique character is equals to k, then sub counter needs to be incremented. So this needs to be done at the end. And this is it. After the completion of this algorithm, you need to return this value as well, to return whatever this substring counter is at this moment. So now let us check that what is the final value, right? So let's check this out. And all right, so it is saying that index 97, where is this index 97 coming? It is at line number 27. Let's check. 27 removed equal. Okay, so it has to be minus. So let us run it again. So this is our final output, which is coming out to be 3, which was required as well. So this is how we are doing this question. So now you people have to understand. So the basic thing that you have to understand here is that how whatever we have discussed in the algorithm. So even though it was very simple and you people can do it, right? You have to basically see to this point that how we are trying to convert all the logics that we are discussing in the algorithm into code. So we are doing exactly the same thing that we were discussing in the algorithm. So you have to try to map these two things together. Did you people get this point? That what we're doing in this particular question, how we have mapped the algorithm to the implementation part and how simple it was?
Ma'am, how did you implement the logic of hash table? Like you have taken integer array and here you have taken char minus a. Ma'am, this one I am not understanding.
All right. So for this, other than this, all the part of the algorithm are clear?
Yes, ma'am. That was
All right. So now you can look here. So this algorithm we have run, right? And now I want to check that what is actually happening, right? So see, when you are having some sort of character, and inside that if you have this a, and if I want to print this ch in terms of its integer value, so you have to understand this one thing, that JVM basically store all of these characters in the form of ASCII code only, right? And ASCII codes are nothing but some numbers, right? So I just want to see to it that what is that exact number that we're talking about when we talk about a. It is saying that ASCII code for this CH is 97, right? Now what I'm saying is that, can you do one thing, that can you subtract uh, from this CH, we want to subtract A. So when we do any sort of like mathematical work on the characters, right? So mathematical things, if you want to do on characters, they first are going to convert all your characters into integers, right? Integers means these ASCII codes that they represent or they map to, right? And then they're going to do all sort of computation. So now CH has become, because now you're doing some subtraction operation, now implicit conversion will happen, right? So this CH will be converted to 97 and this A is also a character. So it will also be converted to 97, right? So 97 minus 97 will become 0. So that 0 is coming out as our answer. And that is what we are trying to do here. That is, if A is there, then we are subtracting it to A so that we can get A 0 as the answer, which is our index, which we have thought of in our mind that 0 will be representing A. Right? In the similar way, if we are talking about C, suppose, right? And in this time we are saying C minus A. So again, the ASCII conversion will happen automatically inside, which so 99 minus 97 you're talking about. So that's why you are getting 2 as your final answer, right? In the similar way, if you'll go for suppose S, so S minus A, so whatever ASCII value of S is there, that will be subtracted from A, and because they are like on a continuous path, so A is 97, then 98, 99, because they are having all ASCII codes are basically continuous in nature for these lowercase alphabets. That's why we can basically make this hash table out of it. Does this make sense?
Ma'am, in the earlier example, when you were printing the value of A, the ASCII value, you have implicitly written like int of A. And here you are not writing.
Right. So I was explicitly writing there that I have to convert it into an integer. But again, I have said this thing that if you're doing any kind of mathematical operation, then the first thing that will happen here is that an implicit conversion, and in fact, there is no sort of conversion as well. Actually, conversion happens when you are basically trying to print the numbers onto the screen, these characters onto the screen. So what happens is that when you write here that I want to print this A, right? So the storage always in the memory, the storage of A will always happen in the form of 97. So in actual, the conversion happens when you want to print this A, right? So 97 is mapped to A and then is printed over here. But now you're saying that you have to just do the subtraction. So in subtraction, there needs there is no need of doing any sort of conversion. Both are stored as numbers and we are doing subtraction because all the characters internally are stored as integer values, right? So conversion happens when you want to print these characters in the same format uh, as they are on the keyboard basically, right? You don't want their numeric representation, you want their actual representation. So at that time conversion happens, a mapping kind of table is there where it is written that 97 means A. So whenever 97 is basically what I'm trying to say here is that this kind of operation happens, that char 97 is converted into a character. So this kind of conversion happens every time. Does it make sense?
Yes, ma'am. Okay, ma'am. I understand.
Right. So this kind of conversion happens and then it is printed in this format, right? So let me show you this as well, right? So this kind of conversion happens and this is how A is printed. So each of these alphabets are stored in 97, 90, their ASCII codes, and then this explicit or implicit conversion is happening, and that's how A is coming out. Right? So whenever you're doing any kind of mathematical operation, there is some mathematical operation happening on the ASCII values, and that's how we are getting those 0, 1, 2 as our indices. Is it clear,
Yes, ma'am.
everyone?
Yes, ma'am.
All right. So now let's move to the next question. You people can try this one. This was Leetcode 1100. You can try this afterwards as well. And I hope that this makes sense, this complete algorithm and this explanation, this makes sense. And now let's go to the next question. And the next question is, all right, a very interesting question is there. So we'll try this one. which is, so this 1876 you people can try yourself. It is very much similar to the question we have just tried, right? So basically even more simple. If we'll compare these two questions, it is simpler version, right? Now we have to go for the next question, and it is all right, 1984. It is lead code question 1984. So let's try this one out. So lead code 1984. This is also a very simple question, but it is like a little bit interesting as well, right? So let's see this one. So it is saying that you have to find the minimum difference between highest and lowest of K scores, right? So suppose we'll jump directly to the question. So it is saying that suppose you are having these numbers 9, 4, 1, 7, right? So they, and K is equals to 2. So suppose you are asked to make the groups of 2, 2, 2, 2 values, right? And then you have to find out that in which particular group the difference between the minimum and the maximum uh, uh, is the minimum or maximum is minimized, right? So you have to find out that which particular pair inside this nums array will have minimum difference that is possible. So now this question is basically very simple, but it is a little bit harder when you go for the question part, that is problem statement part. So I'm going to explain you this, that what they're saying is, and how this is not a direct sliding window question. So we have to first of all try to understand this particular question. So suppose these are the heights of all the members, or these are some sort of like the marks of the students that are there, as the question has said, right? So suppose we are trying to make a group of two people, right? From this array we are trying to make a group of two people, because the value of k was 2. So the first group that will come out is 9 and 4, right? It is basically a problem of your combination, right? It is not a problem of permutation, because 9 4 is equals to 4 and 9. So 9 and 4 is one group, then 9 and 1 is one group, then 9 and 7 is also one of the groups. Then 4 and 1 will make a group, then 4 and 7 will also make a group, right? And then 1 and 7 will also make a group. So these all groups are possible. And now it is saying, the question is saying that you have to find a particular group where the difference of the minimum and the maximum was minimum, right? So the difference of minimum and maximum here is 9 minus 4, which is 5. Here the difference is 8. Here the difference is 2. Here the difference is 3. Then here the difference is 3 again, and here it is 6. So the minimum difference that is possible is 2. And this is what you have to return, which is you have to return 2 as the answer. So we have put this question inside the sliding window concepts, but still we cannot see it happening over here. We cannot see any kind of window sliding, right? So now my question is that how do you make it a question of sliding window first? And second is that if suppose you want to go for brute force, then what approach are we going to use to make all these combinations? So my first question is that how to get all these combinations, right? All these combinations, how can we get? And you have to remember this one thing, that the value of k can change. Right now it is 2, so it is looking very simple. But later on, the value of k can become 3 also, it can become 4 also. The group count can change. So there can be 4 members in the group, there can be 3 members in the group. It is completely dependent on the value of k. Whatever the value of k will be, that will basically tell us that how many members are going to be there. So this is the first thing. So first of all, I want to know that what is the brute force approach to get this combination of all the groups.
Backtracking.
That is recursion.
Yes, ma'am. Recursion.
Recursion, right? So we are not going to use it over here, but recursion is one of the ways, because we have already seen a few of the algorithms where we were using recursion to find out the combination, right? So we can use that,
Yeah.
but it is going to increase the time complexity a lot. So that's why we don't want to use it. Right? So recursion is definitely one of the solution, but we are not going to use it. Is it clear, everyone?
Yes, ma'am.
Yes, ma'am.
Right? So now we want to go for some other approach. Right? So this is very interesting. So let's see. So the other approach says that suppose you have to minimize the difference. Right? Let's say that there are like 4 or 5 people. Right? They're standing side by side. So let's say that this is a person number one, and his height is suppose let's say the height of this person is 5 feet. Right, then the second person is there, and the height of this second person is suppose 6 feet, or otherwise, let's say 5'6" is the height. Then the third person is there whose height is, let's say 5, 4. Then some other person is there whose height is 6 feet, suppose, and then another person is there whose height is 4 feet. Right, so something like this is happening. Now what happens is that we have to find the minimum difference between the lowest and the highest element in a group. Right. So let's say that the value of k is equals to 3. Now we'll try all the groups, but obviously the problem is that when we'll try to group them together, the recursion is going to take a lot of time. So we are saying that let's do one thing, that let's sort these elements first of all. And why we are sorting that also I'm going to discuss with you people. So first of all, let's just sort these all elements here. So when we will sort these elements, so this is 4, this is coming for the first number, then this is our 5, so this is 4, this is 5, then the next element will be 5, 4, so this is 5, 4, then 5, 6 will come, so this is 5, 6, right? And then last would be 6, so 6 will come here. So when you will sort these elements now, what will happen is that you don't have to go for all the groups. Now you don't have to try all the groups. And the reason is you already know that if you will make a group in which the smallest element is 4 and the largest element is 6, now you can change the in-between element because you need 3 elements, right? You can change the in-between element, but you will always get the difference of 4 minus 6 to be the largest of all the groups. So you don't want to make a group in which 4 and 6 are coming together. Does it make sense? The third person could be anyone, right? Because he or she is going to be somewhere in between only 4 and 6 because we have already sorted the elements, right? So now we have understood one thing, that we don't want to put 4 and 6 together any which ways, right? So using sorting, what we are doing here is that uh, we have put these elements in a way that all the elements who are like uh, almost equal in height, we can say that almost comparable in height, are standing together. Now if you'll slide this window, you'll always know, you don't have to even try all the elements now. Now if you're going to slide this window through this array, so the first group here is going to have some difference. You can try this out, that whatever difference is there, but you always know that the difference is going to be somewhat lesser than the group which is going to contain 4 and 6 together. Right, then you can slide this particular window now. So now you're saying that, okay, let's try some other window as well. So this was the first window, and the answer of this window was coming out to be 1, 4. So this was the difference for the first one. Then we'll slide this window a little bit. Let's see the next window's answer. So now this window is slided over here. And now the difference is coming of the minimum and the maximum is coming out to be 5, 5, 5, 6 minus 5, which is 6 inches, right? Then you will go further into the window, and now the difference is coming out to be something 8 inches, right? So obviously the second group was having the minimum distance. So this is what happens when you sort these all elements. Does it make sense that all the elements which are comparable to each other, which are like almost of equal height, are coming together? Hence, we are reducing the differences a lot. And that's how we are going to get the final answer in less time complexity. Does it make sense?
Yes, ma'am.
Yes, ma'am.
Did this point make sense, that we are sorting these elements so that we can reduce the number of groups that we were trying before? We were trying every possible group before, but now after sorting, we don't have to do that because we can simply exclude all the groups which are not in the range of 3 or k elements, right? Is this part clear, guys? Why we're going for sorting?
Yes, ma'am.
All right. So now what you people can do is that first of all, you can do the sorting, right? After sorting these elements, the next thing that you can try is you can simply slide your static window of size k, and in that you can simply subtract the left element and the right element, that is right minus left, you can do. And whatever the minimum value you're going to get, that is going to be your answer. You have to minimize the difference of right minus left. Right, so this is basically now your question has uh, basically become this much, right? So you have to simply do a sorting and then you can go for sliding window approach. Try this one. This is your question number 1984. And you can try this one first and then I'll also try to implement this one. So 1984, this is the question that you people are trying now. This is question number 1984. Try this one out. Very simple. Try this one. If you people don't understand that why we're doing sorting, then you can simply ask me again. I'll explain it again. Right? But try this one first. Is it done, guys? Three, 4 minutes. All right.
Hello.
Yes, Uchi. Done.
Yes, ma'am.
Very nice. So we're going to start with within 2 minutes. Let's wait for 2 more minutes. Submitted on Leetcode as well, right?
यस मैम, लीड कोड पे ही कर दो। हेलो।
Yes, yes, yes. Should we start with the solution now? So very simple question, right? I'm going to do it over here. You people can try it on lead code as well. As simple problem is this one is very simple. And if you see the topics, it is written here that it is sliding window question, and it was asked in weekly contest 256 as well, right? And sorting is also written. So that's how we know that this is not a that recursion question, right? So we can simply go for its implementation over here. So this time what we're doing in this question is done. So if it is done, then we can skip this question. I think that you people will be able to do it, right? Let's try for the next question. The next one is
यस
and also one more thing, that rest of the questions. So we are going to try some few questions we're going to discuss over here. And then from tomorrow onwards, we're going to discuss dynamic sliding window. So the rest of the questions you people have to try yourself because they're very similar to each other, right? So let's try this question. It is a little bit, it is very much similar, but a little bit, you can get confused sometimes, right? If it will come into your online assessments or something, then maybe you people will think that, okay, this is a permutation question or combination question. So do we have to go for recursion or something? So that kind of thing can happen. So that's why we're going to discuss this one as well. So what it is saying is that suppose you have to find out permutation is in a string, right? So very interesting question and very simple as well. So it is saying that suppose you're given with two strings, S1 and S2. So you have to return true if S2 contains permutation of S1, right? Now permutation of S1 simply means, so what is permutation? Permutation is basically arrangement, right? Arrangement means that if suppose the first string is ABC and the second string is BCA, right? So suppose S1 is a, B, C, D, and S2 is A, B, C, or otherwise S2 can be B, C, A, or otherwise S2 can also be DAB, right? Now it is saying, suppose S1 is this bigger string and S2 is this smaller string. So it is saying that does this S1 contains a permutation of S2? So permutation of S2 means, so how many permutation of this strings are possible? So you will say that ABC is one of the permutation. The other permutation is BCA. Another one is BAC. Another one is ACB, then CAB, then CBA. So these six permutations of ABC are there. Out of this six permutation, if any one of the permutation can be found in S1 string, right, as its substring, then the answer will be true, otherwise it will be false. So for S2, can we find any of the permutation of S2 in S1? So obviously direct permutation is available. So the answer for this particular S2 will be true. For this S2 where BCA is given, right? So we are trying to find out any permutation of S2 in S1. So obviously BCA is having one of its permutation ABC inside S1. So then again the answer is coming out to be true for this case as well. And for this particular S2, if the value of S2 is DAB, then is there any permutation of DAB present in S1? So the answer is going to be, is there any permutation of S2 in S1 for DAB?
No, ma'am.
No,
नो मैम।
because we are talking about substring, right? We are not talking about that any subarray or something. We're talking about not subarray. We're not talking about some sequence or subsequence. We're talking about substring here, right? So that's why the final answer is going to be here false, that no. this DAB is not, and any of the permutation of DAB is not present. So even though A is also present, B is also present, and D is also present, but permutation is not present, right? So that's how we're going to uh, go for the solution part, right? Now, how do we solve this question? Let's discuss that as well. So suppose the first string is A, B, C, D, right? And the second string is A, C, B. And we want to find out that uh, do these two strings, like the second string, is this a permutation, is the permutation of the second string present in the first string or not? So for that, the simple approach that we can use here is that we can simply make a hash table in both of the cases, right? So here the hash table will contain 1, 1, 1, 1, 0, 0, 0, 0. Right now we want to check that uh, will this hash table work or not?
Yes, ma'am.
Will it work? Are they talking
Yeah.
about substring or just a permutation? If they're talking about permutation, then the answer for 3 will also be true. Let us check. So AB, this one is true, then AB, this one is false. So we have to see in a continuous window as well. All right. So we can simply go for something like this, na? We don't have to go for this kind of construction. What we have to do is that this is our ACB and we want to find it out inside this particular string, right? So we want to check that how many times, if suppose the question can change to that how many times this permutation has come. Right now it is pretty simple. It is just asking that is there any permutation or not. But the question can change to that how many permutations are available as well. So what we have to do is that this ACB is fixed, right? The second string is fixed, so we can keep the count of ACB inside this hash table. So this is hash table number 2, which is for string 2. And this
Mm.
string 1 hash table is there, which is for the window, right? And the size of window, what will be the size of window that we need to check inside this first string? If
Uh,
you want to, if you,
Size of the second window.
yes, so if you want to check the size of, if you want to check any permutation of second string in the first, then it needs to be equal to the second string. So that's why the size of window is also going to be 3. And we are going to check for this ABC, that is the first 3 character first. So we have marked these 3 variables as 1 here. So A, B, and C. And now we are going to match that are these hash 1 table and hash 2 table equal. If the answer will be yes, then we will say that yes, this is a permutation and we can return true, or otherwise we can increment the count to 1, right, based on the question. If the question is saying that you just have to return true or false, then you can simply return true or false. If the question is saying that you have to get the permutations, then you can keep the count as well. So we are right now keeping the count. So we are saying that, okay, one permutation we have found out. Right now we are going to move this window again. So now we are saying that, okay, let's move this window a little bit. So now,
मैम कंपेयर मैम कंपेयर कैसे करेंगे हैश वन हैश टू को?
so for comparing, you can simply use a for loop, right, of size 26, for loop of size
कॉम
26, in which you're, that's okay. It is like, it is going to run for 26 time, but there is, uh, this is basically needed and this is not very time consuming as well. Right, so you can go for comparison of these two hash tables and you can simply check that if hash 0 is equals to hash 2 0, then it is okay, and so on for 1 2 3. So hash I should be equals to hash 2I. That is how you're going to simply check for it, right? Then you're going to
या
move this window a little bit. So now you're saying that, okay, let's move this window. Now, if this will be a permutation, right? So whatever element needs to be removed, that you may have to make it to like minus minus, you have to make it to 0, or any, you simply have to subtract the count of this A because it is going out of the window, and any new element that is coming inside the window, that you have to mark as 1. And now again, you have to check and compare these two hash tables. If the answer is that yes, both are containing equal numbers at equal positions, then obviously this is a permutation, otherwise not. So here, this hash 1, 0 will not be equals to hash 2, 0, because here it is 1, here it is 0, so this is not a permutation. So we will not increment the count of permutation. Then again, we are going to move this window further. Then this time CDA. So this B will become 0 and this A will become 1. And now again, when you will compare, so the first element are equal, but the second elements are not equal. So this is also not a permutation. Then again, we will move this window a little bit further. So DAB, this time, this is 1, but C will become 0. And again, when you will compare these two windows, again, the hash tables, again, these will not be equal. So this is also not a permutation. Then this is a third window, this is a last window in which this D will become 0 and this C will become 1. And now again, when you will compare hash 1 table and hash 2 table, then they're equal. Equal means that the count of your permutation substring will increment. So that's how we're getting the final answer as 2. That is, there are two possible permutations that are existing in the main string. But your main question is not asking for this number of permutations. It is only asking us that is it possible or not. So as soon as you will get the first match, you will simply return true from there. So this is your question, and that's how it is even more simpler. Does it make sense, everyone?
Yes, ma'am.
Online guys, does it make sense?
Yeah.
Everyone else,
Yes, ma'am.
right? So I think that this makes sense, right? And let's try to solve it first of all. So you people take some time, try to solve it. If you won't be able to do it, then I'm going to help you out, right? But first of all, you people try.
Okay.
And all of the question in the list are pretty simple, so you people can try them yourself. If there'll be any doubt, then you people can ask. Otherwise, I think that they're doable, right? So these were like simple, uh, I would say that differences were there or different type of questions were there. For a static window, for a static window, we are not having very complex type of questions. And if there are some hard questions, then they do carry some different concept as well, which we need to learn, right? So simple, like exact implementation of a static window will come in these questions only. Otherwise, some other concept is always included. So for that, we have to wait a little bit. And other than that, I think that all the other questions are doable. So you people can try that. But first of all, try this 567. Then we'll move further. And attend these classes daily so that you people can basically target any sort of companies that you are basically trying for.
मैम एजेंडास में नीचे बैक ट्रैकिंग लिखा हुआ है, वो शायद हमने पहले कर लिया है.
Backtracking approach is obviously there because it is talking about permutation, but we want to go for this sliding window approach this time.
नो 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 मैम, आपके एजेंडा वाले लिस्ट में शायद जो आपकी वर्ड अभी क्या बोलते हैं यहाँ पे प्रॉब्लम्स लिखे हुए हैं.
That is a very big list. We'll see it afterwards. That we are not going to cover right now.
ओके.
Ma'am, where did you share the agenda page?
I didn't share anywhere. You have just seen it in the
Guys,
on the screen itself.
Oh, I thought that you have shared somewhere.
You will try to submit this question first.
Okay, ma'am.
Are your exams done? Like, Have you given your exams, guys?
Yes, ma'am, I have given. My semester has ended.
Ended already?
Yes, ma'am.
And when will your next semester start?
I think it would be around 5th or 6th Jan.
Acha, which university?
AKTU. Mm,
Third year,
no, ma'am, second year, third semester.
second year, all right. Third semester
Yes, ma'am.
or fourth semester?
Third semester, ma'am. Fourth semester.
Acha, all right.
My semester is done and exams are done, but I'm preparing for IELTS and GRE.
That's very nice. So how do you get so much time? Like, how do you go for your computers related studies? Are you preparing for AI or something else as well?
In daytime, I dedicate my time to these placement
Technical stuff.
preparation, and I'm in
Uh-huh.
nighttime. Usually, I try to get a mock test for IELTS and GRE.
And I always say that just keep your health in check as well, everybody, right? And you have to always keep track of your good health as well. Do some, like, this will sound very not so much inclined to the subject, but then you have to do a little bit of exercise as well, everybody, you know, because that will keep you mentally strong. That will help you to do all these questions nicely. Right? For technical education, I'm here to support, but for your mental health and for your physical health, you have to keep that in track as well. Otherwise, what will happen? At the day of your interview only, you will get cold or, something will happen. So we have to keep check of the health part as well. You have to keep that also in line. Is it clear, everyone?
Yes,
Yes,
ma'am.
ma'am.
Ketan, is
Ma'am,
it
was it
clear?
talking about I?
Huh?
Was it talking about IEL exam for English?
Yes,
He's talking about
Okay.
IELTS only.
ma'am. Suddenly, the companies have stopped visiting my campus. I don't know what's the reason. Maybe it's the calendar thing or something. But now, even or not, like the rate has come down to one company a month now.
For which year?
Ma'am, I'm in my eighth semester now.
It means third year,
Fourth,
My
fourth year,
fourth last
Fourth.
fourth
semester.
year.
fourth year. अच्छा, अच्छा.
But ma'am, I've given my
I think that
off-campus
they'll
round
come. No,
for.
no, no, they'll come. They'll come in January, February maybe.
Yes, ma'am.
Because
I
at
am in
this
stuck.
time, at this time what happens that because Christmas holidays are also coming, so sometimes in the month of December and January they don't usually visit, but then again they'll come. I think from January itself they'll start to visit because most of them are operating in different nations where Christmas is a very major kind of holiday. So don't worry, don't be distressed about that, right?
मैम अभी 7th सेमेस्टर में इंटर्नशिप ले ली है एक स्टार्टअप टाइप्स में.
That's very nice. And
बट
how are
बट
you
उसके चलते वो जो कॉलेज में कंपनीज आ रही है उसमें नहीं अप्लाई कर पा रहा ना.
So is it going to get it'll get converted into a full-time opportunity as well?
या मोस्ट प्रॉब्लम. बट मैम स्टार्टअप है तो पता नहीं कि चलेगा कि नहीं चलेगा उतने दिन तक.
So you can talk to your TPOs, na? Talk to them.
हम्म.
मैम
They'll
मेरे
they'll
दो
guide.
राउंड फाइजर और एचएसबीसी के निकल गए.
Huh?
मैम मेरे दो राउंड टेक्निकल राउंड्स फाइजर और एचएसबीसी बैंक के निकल गए.
Acha, that HSBC is very nice. You can start from there. So do you have like ML kind of like data science or data engineering kind of stuff? Like, have you covered that portion a little bit?
Yes, ma'am, I'm good at machine learning in general.
Uh, then it is nice.
Ma'am, for
I think
Pfizer,
that
it's
is
a back-end
correct.
engineering role, and for ma'am HSBC, it's a analyst role.
Because HSBC में usually they come for analyst or machine learning specialist kind of roles only.
Yes, ma'am.
So good going, good going. So don't get only one thing that you have to keep in mind is that don't get distressed. Exercise regularly, and all the things will happen. All the things will fall in place. You have to keep
Yes,
this in
ma'am.
mind.
Yes, ma'am.
कॉलेज में कंपनीज आती हैं केतन बोल रहे हैं कि नहीं आती. So Ketan, you have already done your college, all right. So colleges में companies आते हैं. You just have to actually with with who the thing was that there was some like, all right, we'll not discuss here the personal things, right? So companies visit, and he's a very studious child as well. So it's just about the time, right? So you just have to wait for your time to come and
मैम एक दो महीने
just
बहुत लगातार आई थी, लाइक हफ्ते में दो तीन आ रही थी, अब एकदम से
yes.
स्लो डाउन हो गया.
Then again, they'll visit again in the month of January, February, most probably. Right. So is
Ma'am,
this done for 567,
Yes.
everyone? That's okay, Ketan. Agar, abhi I don't know that what your current package is, but if you will keep on doing these things, right? If you'll prepare well, one of the like right now AI is trending, so if you will do something from that area as well. So definitely anybody can get a very good package in the field of AI right now, and it is not very difficult as well. So we can try that as well. है ना? So with DSA we can crack the initial rounds, and later on with some good projects, it's very easy to get a decent package. The the thing is that we don't have very much good engineers out there. So we usually say that companies don't hire or something, but if you will see the crowd that is around you people, you will understand this by yourself that not everybody is very much serious about this stuff. So there are opportunities, there are good packages. It's just about uh, getting serious about these opportunities and about the learning, right? I always say that if you are serious about your subjects, if you are serious about your field, and if you love your field, then you will always find something new to do in this field. And that's how you'll get the opportunities as well. You have to be just a little bit curious, that's it.
You're talking about ML classes.
ML classes, I'm saying that if you're having good technical skill as well with DSA
No,
and
no.
system design.
And
Yeah.
you messaged in WhatsApp after me few days ago.
I was saying JavaScript class. ML will start after that, so that we
Okay.
can make some good projects also using web development and ML. We'll learn some few algorithms from ML section as well. But first of all, I'll not I don't want to disturb this particular zone. So we want to complete
Yeah.
our DSA and system design first of all, very
Mm.
quickly. Quickly in the sense not by not using our basically we don't want to run away from the topics. We want to cover them all, and that's how we want to move forward. And then we'll be doing system design, then only we are going to jump to any other thing. First of all, DSA and system design, these are our two main targets, right?
Mm.
Right. I'll see to it. The Netflix clone, I have not seen it. I'll see to it first. All right. So I think that these questions are with you people. If there is any doubt, I'll solve it in tomorrow's session. Most probably, we'll start with dynamic sliding window only because that is very interesting. You'll find it very interesting. But other than that, you people can try these questions, right? Very simple, and this will give you a boost as well, right? So we'll end our session for today here itself. So you people can take a screenshot of this screen, and then you people can try this one.
Ma'am,
Is it that?
one
Yeah,
more request I want to make.
yeah.
Ma'am, can you take a session on optimizing the resume?
Yes, ma'am. I second this, if
I'll
possible.
arrange. I'll arrange. Maybe some other trainer will take it. I'll arrange one session.
Okay, ma'am.
Okay.
Thank you.
Okay. All right, guys. This is it for today's session. Right. We're going to meet tomorrow. Right. Same time, 8 p.m. I will start with dynamic sliding window. Right. Good night and take
Yes.
care, everybody.
Thank you, ma'am. Thank you very
So,
much.
You too.
guys.
Thank you, ma'am.